The design process is used anytime we want to document our building process for any kind of technological object. You will be building something Monday morning. You will be using the design process. The first step to any design or experiment is always the aim, the goal, or the problem statement. In design, they mean the same thing. In other words, what is the point of you trying to accomplish or do this thing? Okay, what are you trying to accomplish? You will be given a task. So in the case of your arm, okay, we're going to use the arm as the example throughout this, the record player turntable arm. The whole point of that project was to build an arm that could draw a spirograph image onto a piece of paper, right? That's your aim. So your aim or your goal or your problem statement is what you want to accomplish. So just for format's sake, this one does not have to be in the form of a question. It can be a sentence. The aim of this project is to accomplish this task. Done. Okay? Next, we go into something called the design plan. And the design plan is divided into two separate things. One of them is your constraints, and the other one is your design criteria. When we talk about design criteria, it is the overall outcomes that our technological object must accomplish. Last year in your lab exam, you had to build a boat that sailed a distance of 2 meters in a straight line. Okay, you had two things that you had to accomplish there. You had to get a boat. Well, first of all, regardless, you had to build a boat. That doesn't count. That's a given. But that boat had to sail, number one, in a straight line, and number two, it had to go a distance of 2 meters. So your design criteria here is what your task or what your object has to accomplish. You have to build it to the specifications that are going to allow you to accomplish a certain task. That is your design criteria. Usually, a good hint is to look at the number of marks that it's worth, and it usually tells you how many criteria there are. Okay? Constraints or limitations. What are you limited by? Usually it's things like materials, manpower, time, money, all kinds of things that normally you do all of this. Now you do your aim, your design criteria, and your constraints before you even start touching any tools or materials. Okay? This is kind of like the equivalent of your problem statement and your hypothesis of an experiment. This is done before you actually do your work. Then we move on to the idea of brainstorming. Now, brainstorming involves sketching. It doesn't have to be perfect, but it has to be legible. Legible means I have to be able to understand it. Now, the rule of thumb is normally about 3 ideas. Okay? 3 good brainstorms, a minimum of 2. You cannot go in there with just one idea. Okay? Because that shows that you have not put any thought into your prototype. So brainstorming, you're going to come up with some sketches, and you're going to label those as to what materials you're going to want to use. Okay, so it gives the person looking at this a real clear idea of what it is you're going to try and build. Then what you've got to do is you've got to rank them. You've got to tell the person which one you're going to go with and why. So after you're done this, you have to rank them. Okay, you've got to rank your ideas and choose what you think is the best one. Okay, and give a reason as to why it's the best one. That is going to be what you originally build. So then we have our iterative process. Okay, and this is documenting changes and improvements. Okay? Question?
For the iterative process, when we're writing it, are we allowed to use personal pronouns or no?
You should not use personal pronouns throughout all of this. Okay? You should get out of the habit of using personal pronouns. Just be direct. The cardboard was changed for plastic board because it's sturdier. Done. Okay? Cool? All right, now, the iterative process usually finishes either when you run out of time, okay, and I take your paper away from you, or you're happy with what you've constructed. Okay? One or the other. One or the other is going to happen. And I'm telling you right now, I will stop you. I will stop you during that morning session to work on your booklet. So that you don't, because some of you, I'm sure, could get lost in just building for an hour and 45 minutes. And you'd have a great old time, and then you'd have nothing in your booklet. So I'm going to make sure that doesn't happen. Okay, I will stop you at the hour mark, and I will tell you, go work in your booklet. If you finish your booklet, and you're happy with what's in your booklet, and everything's complete, then you can go back to tinkering. Okay? And what you can do, in case, you can just submit a picture. You'll bring your iPads with you. You won't use them. But if for some reason you get a chance afterwards to go build, you're not going to have time to go and redo your whole booklet, right? So you can just make a note and say, please see final image. And you will email me the image. Okay? And I will make note of that when I mark it, in order to mark your actual prototype. Okay? So, let me finish. Now, just to go over this, your iterative process is done when you have your final prototype. If you have any diagrams to make, like 3-view drawings or diagrams of principle and diagrams of construction, you will make them of your final prototype. Not your initial one, because that's going to be changed. Okay? So just like a conclusion in a scientific method experiment, here you're going to not only give me what your original aim was, you're going to remind the reader what the original aim was, but instead of saying whether or not you reject or accept your hypothesis, you're going to state whether you've met or not met your design criteria and why. Technology is constantly trying to improve upon itself. If that wasn't the case, we'd all still be driving cars that you have to sit there and crank, okay? And they could maybe go 5 kilometers per hour. It would literally take me 8 hours to get home, okay? I wouldn't be working here and living where I live. Now, the thing you've got to finish with are improvements. Now, improvements, there is no such thing as, my design was really great and I wouldn't change anything. There's no improvements to be made. No, that doesn't exist. Just like saying, this experiment was wonderful. There were no errors and I learned a lot. No. Okay? No. There are always, always, always ways to improve. You got to come up with, the usual is at least 2 or 3 improvements, suggested improvements. And stating that I didn't have enough time is not an improvement. It must be improvements to your build. It cannot be improvements to the situation. Okay, because that's the point of the situation, to give you a time constraint. So it's how can you make your build better? Not if I had more time, I would have done this. No, a way to improve what I ended up with would be to do this. Okay? That is the design process.